This lesson is going to look at taking those special products that we talked about a few lessons back and looking at how to factor those. If you recall, there are two of them. One of them is a difference of squares because both of them are perfect squares that you have, and there's subtraction in the middle. So it's x squared minus 9, x squared minus 25, x squared minus 36, and x squared minus 16. All of those terms in the binomials are difference of squares. Remember when we did this before, we took the first term and we squared it, and we took the last term and we squared it. And that was how we got each term in the binomial, and then it was always subtraction. So in order to go backwards, instead of squaring something, the opposite of squaring is square rooting. So I want to square root both terms. So I want to square root the x squared, and I want to square root the constant term. So remember, with the difference of squares, the two binomials were exactly the same, except one was plus and one was minus. So I'm going to have x plus something times x minus that same something every single time. Okay, and so the square root of x squared is always x. And then I have to look at taking the square root of the last term. The square root of 9 is 3, so it's going to be x plus 3 and x minus 3. The square root of 25 is 5, so it's going to be x plus 5 and x minus 5. The square root of 36 is 6, so it's going to be x plus 6 and x minus 6. And the square root of 16 is 4, so it's going to be x plus 4 and x minus 4. The other type we had was the perfect square binomial. So this one is a little harder for me to recognize when it's in a trinomial form, because I don't always necessarily recognize that the middle term is twice the product of the two original terms. Because remember, with these, it was the same binomial times itself, or basically that binomial to the second power. So remember what we did with it. We took the first term and we squared it. So in this one, we're always going to take the first term and square root it. So for these, both of them are going to be x. Now, all of these, all three of them have plus signs. So it tells me the signs are going to be the same, and it tells me then that this one's going to be plus. So we know it's going to be x plus something squared. This one's going to be x plus something squared, and this one also is going to be x plus something squared. So looking at this one, then I have to take the square root of the last term. The square root of the last term is 1, so square root of 1 is 1, so it's going to be x plus 1 squared. Square root of 4 is 2, so it's going to be x plus 2 squared. The square root of 9 is 3, so it's going to be x plus 3 squared. Now, these you don't necessarily have to recognize as perfect square trinomials. Like I said, I don't necessarily always recognize them, so we could still factor them the way we did before. So like if we're looking here at this middle one, I could say that my first terms are going to be x, just like before, because the only way to get x squared is x times x. And then I need two numbers that multiply together to make c, but they have to add together to make b. So my options of 4 are 1 times 4 or 2 times 2. And I'm looking for two of them that add together to make b, which is 4. So 2 times 2, if you add the 2 and 2 together, is what gives you the 4. So I would have, this tells me that both signs are the same. This tells me that they're both positive, so it's going to be x plus and x plus. And my factors are both 2, so it's going to be x plus 2 and x plus 2, which simplifies to x plus 2 squared. So either way, I would eventually get the same exact answer, even if I did not recognize that all three of those were perfect square trinomials.